Okay, we're going to move forward. So, welcome to our meeting here this evening. I'm Dave Chisholm. I'm the president of the RASCA and the RASC Ottawa Center, and I'm also the interim meeting chair at this point in time. And let's move on. So, welcome to our local members and those visiting from other centers and visitors. We're recording this webinar for posterity, and it will eventually be available at our well-provisioned website. And please use the Q&A box to ask any questions to the speaker. The chat box comments can be seen by everyone, so be careful with that. Raise your hand is disabled. If you do have a question, please use the Q&A box. I will attempt to see what you're asking and pass that on to the presenter. The RASC Ottawa Centre acknowledges the trust placed in us by our First Nations with their ancestral lands and sky. So here's the schedule for this evening. I've got a member in the news as well. Got the Ottawa Skies. Paul Klauninger is our big presenter this evening. He's got some really fascinating slides of his summer travels. We'll have a 5-minute bio break, an AstroTrivia. We have some announcements just before the break, and we have various observation reports and our monthly observing challenges, followed by a couple more announcements after that. We shouldn't run too late this evening. So welcome to our 3 new members, but we've had 60. Welcome to our new members, and we have 3 new members, and we have 66 new members in 2023. So members in the news, Andrea Gironis, congratulations. She had her picture of the sun on the front page of the Royal Astronomical Society of Canada Journal for October. She also had one of her images mentioned inside of that same journal. So congratulations, Andrea. If you would like to become a member of the Royal Astronomical Society, we have 3 different levels of membership. A regular membership is $103. A family membership is $97.50 plus $16.90 per adult and $9.20 per youth. And if you're under 21 years old or under 25 if a student, you have a youth membership that is $62.40. So what do you get for this membership? Well, locally, you get access to the Ted Bean Loan Library. And Peter Shute, who is our librarian, has done a marvelous job of getting the telescopes all fixed up. We've had a number of new donations to the library recently. And we've got some really good telescopes if you wish to borrow some of those. We also have our private observatory out near Almont. It's on the far side of the Mill of Kintail, the Fred Lossing Observatory. We sometimes refer to it as FLO. And excellent site with two domes, a warm room, and a roll-off roof, plus plenty of space for your own telescopes as well. And we have the Stan Mott Book Library, which is at the Canadian Aviation and Space Museum. Good news is that next month we will be there live in person, and we'll have access to that library. Estelle is going over next week or so to go through the library and make sure it's all ready for us for our November meeting. As a member of the national organization, you get the journal, and you also get the Observer's Handbook. It typically comes out in late November, early December for the following year. And every month, you get our amazing local newsletter called Astronotes. Gordon Webster is the editor for that, and you'll be emailed those. The journal you receive electronically, but when you do sign up, you have the option of getting a hard copy as well for an additional cost. But the greatest benefit of being part of the Royal Astronomical Society of Canada are the members and all the people here. So, Oscar, do you want to talk to this?
Yeah, sure. I'll go ahead and speak to it. So Friday, November 24th, starting at 6 with cocktails and 7 p.m. dinner, we're going to have the return of the RASC annual dinner meeting. We're going to be serving the what we've had in the recent past, which is a beautiful buffet featuring roast beef main course, as well as vegetarian options, which I'm still sorting out with the venue. Our speaker is going to be Dr. Sarah Mazrui, and she's going to be presenting. She's going to be talking on lunar exploration, past, present, and future. She is a planetary scientist, which is very interesting, and she'll be great. Give us a great talk. Tickets are $65 each. They're on sale now. You can e-transfer that amount to our treasurer at treasurer@ottawa.rasc.ca, or you can purchase by credit card at the link on the slide there, or we'll also be selling tickets in person at the November meeting. If you choose to use a plastic to pay, it'll add $2 to cover the processing fees. But again, that's Friday, November 24th, 6 p.m. cocktail, 7 p.m. dinner at Algonquin College. Looking forward to seeing as many of you there as we can get.
Okay, thank you very much, Oscar. It's a fun time. I get to meet people, and also we will be announcing the awards for the year as well at that dinner. So I encourage everybody to get their tickets. Yes, for your calendars, we have the RASC calendars for 2024. And good news is I just received them today. They arrived on my front doorstep just before the meeting tonight. So we have 4 different pickup locations that will be set up. And I'm not sure how many we have left. If we have some left over, we will bring them to the November meeting. But if you want to guarantee yourself a calendar, you should get your order in as soon as possible. Some of this information was also in AstroNotes as well. So if you need that weird HTTPS URL, I believe it's in AstroNotes. It may even be on our website. So anyways, we have 4 different locations across Ottawa to pick up your calendar after you have ordered it. That saves you and us on the shipping charges for that. So let's go through the Ottawa skies then for October. It's sort of odd when you're presenting this because we're almost halfway through the month, and so I can sort of show you things that you missed. But generally speaking, most of the exciting stuff is coming up after today. So here are the phases of the moon. Full moon is on October the 28th, and this full moon was known by the early indigenous tribes as the hunter's moon, because at this time of year the leaves are falling and the game is fat and ready to hunt. This moon has also been known as the travel moon and the blood moon. So we also have a new moon on the 14th or 15th. I'm not sure which of those days, probably the 14th. Yeah. And in fact, that new moon's going to be interfering with the sun. We'll have something about that in a little bit. There we go. We have an annular eclipse. Now from Ottawa, it's not particularly spectacular, but it does start tomorrow at 12:06 p.m. And just a little nibbles coming out of the sun from our location. You get further down into the States, and that's where Andrea is right now. You'll have much more coverage. And the maximum eclipse is at 1:14, and by 2:23, it's all gone. And we are having an event here in Ottawa, and there'll be details for that after Paul's presentation. Just a couple of safety things around the solar eclipse. Never stare directly at the sun. And I do a lot of presentations to youth, and I really have to keep emphasizing this because our eyes have no pain sensors. And you stare up at the sun, that your eyes will water, but they don't tell you the fact that the back of the eyes being burned by the intense light of the sun. So very important not to look directly at the sun. If you don't happen to have a set of solar viewing glasses, then make yourself, say, a pinhole box. Basically put a pinhole in one end, put a piece of paper in the other, and have the sun shine through the pinhole and project the image of the sun on the back of the box. That works really well. If your kids are really wanting to see it and you do not have proper safety glasses, it's probably best to leave them inside. And as an example, during the partial eclipse, which is what we're having in 1984, 11 people were left with permanent sight loss from staring at the sun. We will have these signs out at our observation session tomorrow. So we have the Orions meteor shower. So this is on October 20th and 21st. It's a medium meteor shower, 20 meters per hour. The moon is a crescent moon. It's a first quarter moon, but it sets just before midnight. So probably after midnight would be the best time to see it. And this meteor shower is made up of dust left behind by Halley's Comet. Here's the sunrise and set, as we've probably all been observing. Things are, the days are certainly getting shorter. Mercury is not visible at this month. Venus is visible before sunrise. October 23rd is the greatest western elongation, so that means it's furthest from the sun. Mars is not visible. It's rising and setting with the sun. Jupiter is nice and clear in the evening skies right now, as we've probably all seen, as is Saturn. Uranus is visible in the evening and through the night, and Neptune is visible in the evening and through the night. And here's our cartoon of the month. That's what a lunar eclipse is, a solar eclipse, and apocalypse. Thought you'd enjoy that one, appropriate for this month. So I'm very pleased to have Paul Klauninger give us a presentation here this evening. So I'm just going to spotlight him. Just give me a second here. He was here.
I am.
You are. There you are. Okay. You want to turn on your video then, Paul?
Actually, I probably will not, Dave, because
okay.
As I was listening to you, I was again getting some interruption, some chop there.
Okay, so, not a problem.
Yeah, I'll stay with the audio, and hopefully that I'll have enough bandwidth to plow through on the presentation.
Okay, sounds good. I'm just going to then change my virtual background here so that you can see what he looks like. There we go. And then I'll hide myself. That's Paul a few years ago.
Oh, maybe last year.
Well, last year, okay. Anyways, away you go. Just let me know when you need me to move slides.
Thanks, Dave. All right. Well, good evening, everyone. When I was first contemplating doing a presentation here to help Dave out with his scheduling, I thought, well, I've accumulated a fair bit of material over the years here, and certainly in the last couple of years, I've especially since my retirement, I've made a couple of road trips, actually a few road trips through various parts of Canada, predominantly out to the West Coast and up to Northern Ontario. So I thought, well, perhaps I could put something together that people would be interested in, and that it also relates my interest in both astronomy and terrestrial geology. Next one, please. So, to me, these disciplines are linked. I mean, geology and astronomy, they're part and parcel of the same curiosity and the same science that I think many of us enjoy when we look up at the sky. We wonder about what's going on there and how things were formed and got to be there, and that goes all the way down to our planet here, the lovely world that we've fortunate enough to inhabit. And so I thought, well, I've had a long-standing interest in geology, and this map actually shows a number of the road trips that I've done in the western part of Canada over the last number of years. I make it a point that whenever I do an extended trip like that, I like to take roads that are not always the main thoroughfares, off the beaten track, as it were, because there's a lot to see. We're blessed to live in a huge country that allows us to see a variety of landforms and geological features that actually speak to us in terms of the things that they reveal about the formation of our planet and even about our solar system. So I thought I'd put something together. Initially, I was just thinking of a travel log, but I thought I'd like to go a little bit more than that. So I thought I'd combine the travel log aspect with a bit of background on why I'm so interested in this field, especially being in Canada, because we do live in a huge land, second biggest country in the world. And as such, we get an opportunity to essentially cross over a number of different major geological divisions, and each of those have a story to tell about our planet and how it came to be and how we came to be on it. So that's where I thought I'd go with this. I'm going to throw an awful lot of slides at you. So, and the timing on this, I know Dave has given me a fair chunk of time. I may have taken advantage of that and thrown in more slides than I can possibly deliver. But if that's the case, I'll just get Dave to go through some of them, because in the travel log aspect, there a lot of that is a lot of those slides are, if I can put it this way, visual eye candy. They're from a number of fantastic places that one can see when traveling out in the western region. I've also done travels out in the east, but I thought with the time limit that I do have, I'd focus on the western portion, and specifically on an area of high interest. And then perhaps if Dave's in a pinch again and would like me to do a presentation on other parts of the travel where I've spent perhaps less time, I can do that as well there, because I am a fanatic photographer, and I do have quite a collection of interesting things to see. So next slide, please. So the one thing I wanted to mention, I was thinking, like, I want to do something on exploring Canada's geology and skies. As I started doing the presentation, I realized and I actually learned some stuff here that kind of surprised me. While I have had opportunities to do photography on my travels out west, these travels are predominantly in the warmer months in summer, because I don't know, traveling across the top of Lake Superior in late fall or early winter isn't really probably the wisest thing I could do. Weather-wise, it can get pretty rough, and so being more or less self-constrained to the summer, I find myself in an area where, because of the high latitude, the days are longer, the nights are shorter, and in some areas, as you go further north, there isn't even a true nightfall, where astronomical twilight gives way to pure night, and that can go from mid-May to July in some areas there, even at the latitudes of places like Calgary and such. So yeah, the photography can be a little bit limited, but you still get some pretty decent opportunities there. Next slide, please. The one thing I noticed, and you can see that I've circled something down at the bottom there and put a little X there. The X is Ottawa, and this is the Bortle map of light pollution. What I found interesting is that along my route, which I showed you just previously there actually isn't a lot of sky that you would say is as dark as a place like Nirvana or Algonquin Park. I look at the light domes on this map, and I'm fascinated by the extent of them, the spread of them. And it's much more than I expected, certainly because of the limited population in the western provinces. Not quite sure why that is, but one of the reasons I think is that the terrain across the prairies is extremely flat, and so if you have a population center, even a relatively small town, the light dome that it can cast may spread out much farther than a similar sized town would here in Ontario. That's only a guess on my part. I'd certainly be willing to hear from others that have a better explanation, but I found that interesting. I expected there to be a lot more dark patches, but as you can see from the map, you actually have to go a fair ways north in all three of the prairie provinces, especially in Alberta. You have to go up near Great Slave Lake to start getting into some really dark skies there. The area that I've circled is here in Ontario, and we're lucky in that regard. This is an area not that far from Ottawa. Actually, it's an area that encompasses Algonquin Park, and the area between Sudbury and North Bay and Mattawa. In that area there, we have some pretty dark skies there, and so we're quite fortunate. So, long story short, I'll leave a lot of the celestial stuff perhaps for a later talk. I will mention some as I go along the way. But I'll focus on the geological aspect of my interest here, because that's the gist of it, and it's the stuff that I've got a lot of data and a lot of information to pass on to you there. So what I'm going to do is I'm going to provide a brief history here of the various geological provinces that exist on Earth and in Canada, but focus specifically on those that are in Canada. And you can see by this map there, you can see the legend on the bottom left there explains what some of those regions are. And so I'm going to look at the Western ones because those are the ones that I have photographs for and a lot of information for. So our early North American continent was assembled from continental fragments by the process of plate tectonics. We believe this process started more than 3 billion years ago when the production of the continental crust first began. Early Earth consisted of an undifferentiated mass of largely molten matter created by the accretion of materials in the form of planetesimals, asteroids, comets, and meteors circling the sun in the primitive solar system. After this initial formation of our planet and under the force of gravity, the lighter elements gradually migrated towards Earth's surface, and it was this process that began the differentiation of the Earth's surface into continental and oceanic crust. The lightest materials constitute the continental crust. They remain at the surface and preserve some record of the long history of Earth's construction. The materials that constitute the crust that now now lies beneath the oceans are somewhat denser. The continual release of heat from the decay of radiogenic materials in the Earth's interior takes place along the seafloor in the middle of the oceans. And it's this process that causes continental tectonic plates to move across the Earth's surface at rates approximately 3 to 15 centimeters per year. I'll show you an animation of this shortly. Next one, please. So why are we so interested in these rocks and indeed the surface geology of our country and indeed other parts of our planet? It's because the rocks talk to us. The rocks can tell us a great deal about the evolution of a particular body like the Earth, or in this case, asteroid Bennu. Some of the oldest, some places on Earth, like the geological shields of Canada, Australia, and Africa, contain very old rocks on the order of 4 billion light years, give or take. They can tell us a great deal about what conditions must have been like at the time that they formed to enable them to form in the first place. Excuse me. However, those rocks still fall short of the estimated age of the Earth at about 4.6 billion years. This is due to the dynamic reworking of the Earth's crust, accredited plate tectonics, where old crustal material is continually subducted, essentially plowed under into the interior, and new crustal material forms and is pushed up along oceanic spreading ridges. This is one of the reasons we want to travel to asteroids like Bennu to retrieve samples of the earliest materials of the solar nebula. Such bodies are believed to be remnants of the formation of our planetary system, and unlike the Earth, they have no dynamic processes at play to rework the material that comprises them. They are physical samples of that material that have been orbiting the sun relatively undisturbed for 4.6 billion years. Next one, please. So my hat's off to the many thousands of people that made the OSIRIS-REx mission possible. And just recently, the successful return of about 250 grams of Bennu surface. I think we're going to see some pretty interesting science come out of that analysis of that material over the next while, and help us refine our knowledge of how we came to be here in the solar system. Next one, please. So this is the same trip map that I showed you, except that the bright yellow lines are actually the route that I traversed this summer. Whenever I do this type of a extended road trip, I do love to take the opportunity to observe and explore the areas that will lend themselves to a closer investigation and enable me to actually observe and sometimes get hands-on some of these materials that were crucial in the formation of our planet. This summer, I did a month-long 11,000 kilometer trip out to British Columbia to visit my daughter and to explore geological areas of interest along the way. This particular map shows the route that I took, and it allowed me to cross over 3 major geologic divisions that form this land. So those are the divisions I was referring to previously within Canada, and I'm just going to give you a brief overview of those. Next one, please. So the major geologic divisions in Canada, there are 6 of them. They're the Canadian Shield, the Interior Platform, the Cordillera Origin, the Eastern Continental Margin, the Appalachian Origin, and the Intuition Origin. I'll go into a bit of detail here about the 3 westernmost divisions, as these are the ones relevant to my trip this summer and to my talk this evening. And just a bit of definition here. The term orogeny is a mountain building process that takes place at a plate boundary when tectonic plate motion compresses that plate margin. An origin develops as the compressed plate crumples and is uplifted to form one or more mountain ranges. This involves a series of geological processes collectively called orogenesis. These include both the structural deformation of existing continental crust and the creation of new continental crust through volcanism. Magma rising in the origin carries less dense material upwards while leaving more dense material behind, resulting in a compositional difference in the Earth's lithosphere, which is the crust in the uppermost mantle. So in the earliest history, we know that of our continent, we know the North American continent was assembled from continental fragments by the process called plate tectonics. We believe this process started more than 3 billion years ago when the production of the continental crust first began. During the Hadean period, the oldest era of Earth's history, dating from 4.6 to about 4 billion years ago, early Earth consisted of just an undifferentiated mass of largely molten matter. It was a semi-molten blob, essentially, from the heat of its formation. It was created by the accumulation of materials in the form of planetesimals and meteors circling the sun in the primitive solar nebula. And we've seen this, we're actually nowadays with the telescopes that we have, we see this process happening around other stars that we can actually image the accretion disks of those materials. So under the force of gravity, the lighter elements that were involved in this process gradually migrated towards the Earth's surface. And it was this process that began the differentiation of the Earth's surface into continental and oceanic crust. The lightest materials constitute the crust. They remain at the surface and preserve some record of the long history of Earth's construction. The materials that constitute the crust that now lie beneath the oceans are somewhat more dense. And the continual release of heat from the decay of radioactive materials in the Earth's interior takes place along the seafloor in the middle of oceans. And it's this process that causes continental plates to move across the Earth's surface, as I mentioned, at rates approximately 3 to 15 centimeters per year. Next one, please. So one of the major, one of the major areas and divisions within Canada, and I won't say within Canada because this is actually quite an interesting formation, is the Canadian Shield. I mean, it occupies the center of our country. However, that just refers to its outcrop area. Rocks of the Shield actually underlie the interior of the continent beneath the Rocky Mountains, as well as the interior plains of Canada and the United States, where the sedimentary rocks of the interior platform cover them over. That's why we can't really see evidence of the shield in places like southern Saskatchewan, and so because they have a blanket of sedimentary materials covering them to quite a depth. The shield itself is composed of very ancient rocks, some of the oldest on Earth. The construction of the shield involved the collision and the buildup of a large number of tectonic plates beginning more than 3 billion years ago, but this was mostly completed by around 800 million years ago. The cores of most of the world's major continents are created by the same plate tectonics process as we see here. And one of the last major plate collisions involved in the assembly of the Canadian Shield is named the Grenville orogeny. This involves large-scale amalgamation of most of the Earth's continental plates about 1 billion years ago into a supercontinent that geologists called Rodinia. The collision built a gigantic mountain belt that ran northeast to southwest across eastern North America, with mountains probably rivaling the Himalayas in scale, stretching across Quebec, Ontario, south of Sudbury, and down to the eastern half of the continent to Texas. Erosion subsequently removed some 20 kilometers of the crust over the next few 100 million years. And so that when the great invasion of the sea began about 600 million years ago, the landscape was almost flat, and that sea divided the North American continent in half. The next major division is that interior platform. Do we have the next slide there, Chris? Sorry, or Dave? Thank you. Oops. Here, I just got to scooch on my notes here. Yeah, sorry about that. So the interior platform geological region is what you cross over when you either go up to northern Ontario, as you can see here at the Hudson Bay Basin is part of this, and certainly when you cross over the prairies along the Trans-Canada and basically the southern areas, you get the Western Canada Sedimentary Basin. And this region is named for the area of the shield that is covered by rocks from the Cambrian to Cenozoic areas. They're largely flat-lying, and this is the main reason for the gentle low-lying topography that characterizes the landscape. In Canada, the interior platform includes the prairies of Manitoba, Saskatchewan, Alberta, where the rocks constitute the lower half of that Western Canada Sedimentary Basin. It extends northward down from the Mackenzie Valley and then eastward across the Arctic platform, comprising the belt of Arctic islands lying just south of the Northwest Passage. An underlying area of largely flat lying Paleozoic sediment also extends southward from Ontario, as you can see, down the St. Lawrence Valley and across the Gulf of St. Lawrence, although Anticosti Island, or through Anticosti Island to westernmost Newfoundland. Within the Canadian Shield, thin remnants of the same sedimentary rock cover the Hudson Bay and the Fox Basins. All of these areas underwent a major invasion of the sea at some time between 550 and 450 million years ago, which lasted until late in the Devonian period. Excuse me, about 360 million years ago. As a result, a gigantic inland sea developed, probably covering almost the entire continent. In it, some of the earliest invertebrate life forms flourished, including trilobites and brachiopods and corals. The limestones that were deposited at this time are well seen in the front ranges of the Rocky Mountains, in the Niagara Gorge, and even underlying Parliament Hill in Ottawa. Reefs formed by primitive colonial organisms flourished in the area corresponding to present-day Alberta, and became the host for much of the oil and gas that forms the foundation of the modern economy of that province. Next one, please. And lastly, we have the Cordilleran origin. The modern continental configurations began to take shape about 200 million years ago with the breakup of the Pangea supercontinent. The Atlantic Ocean began to open in the east, and the North American continent began a long, slow drift in a northwesterly direction. This took Canada from the equatorial to more northern latitudes for the first time, and the westward drift across the ancient Pacific Ocean caused several large land masses that were located out in the Pacific Ocean crust to collide and become amalgamated with the western edge of our continent. I have a video that I'm going to show you shortly here that puts all of this in motion, but I want to give you the background first so that you understand what you're looking at. So most of British Columbia was formed in this way by the collision, these collisions and the successive collisions, volcanic episodes, and periods of metamorphosis and folding that would largely account for the rugged nature of the Cordilleran belt that extends all the way down from Alaska through the western United States. One of the important effect of the collisions was to push giant slabs of rock lying at the edge of the interior platform of Alberta and the Northwest Territories upwards and eastward along thrust faults to form the front ranges of the present Rocky Mountains. Gravel, sand, silt, and mud shed eastward from this uplift, along with erosion of these rising mountains, began about 650 million years ago, forming thick deposits of sandstone, siltstone, and shale that lie on the Paleozoic limestones of the interior platform. This is what covers the Canadian Shield in the prairie provinces in the southern regions. These deposits stretch all the way from Yukon down through Alberta as far south as Texas. The youngest rocks that form the topmost sedimentary layers immediately to the east of the Rockies originated as debris carried eastward by the ancestors of the present-day Bow and Athabasca River. Subduction of the Pacific Ocean plate continues to the present day offshore west of Vancouver Island. Volcanoes such as Mount St. Helens in Washington State are created by this process. Volcanic eruptions occurred near the Whistler Ski Center only a few thousand years ago and could occur again, though most geologists think that a major earthquake somewhere along the west coast is a more immediate danger. Next one, please. So this illustration, it helps to visualize some of the processes I've been describing. Here near the center, you can see the upwelling of materials from the asthenosphere, creating fresh oceanic crust along a spreading ridge deep under the ocean surface. We see this in the Pacific and we see this in the Atlantic Oceans. The portion of the oceanic plate moving to the right becomes subducted as it collides with the continental plates moving in from the left, as was the case with our North American continent that I just described. This is the process that created Western Canada's mountain ranges, the Cordilleran origin. So to put it all in motion, the next slide is a time lapse. And Dave, if you could, yeah, thank you. There we go. This time-lapse animation shows the believed movement of the continental plates from about 540 million years ago to the present. Not sure, Dave, if that is playing. I don't see it moving on my end of it. It should be. There we go.
There we go.
It was set for to start automatically, but nevertheless. So this shows the believed movement of the continental plates from about 540 million years ago to the present. Though the text is a bit small and maybe hard to make out, you can see the location of a few of today's major cities indicated. I particularly like the formation of the vast sea, the Western Interior Seaway, essentially dividing North America in half, starting at around 110 million years ago, because this was so fundamental to the formation of our present-day landscape that we see now that the water has all gone. There it goes there. You can see it up in North America starting to form. And just see it basically splits the continent in half. There we go. Boom, boom, boom. It's fascinating, the amount of motion that these vast continental plates have undergone in the last 600 million years. You can see we're almost at the present. So what you saw here too is that the very light blue areas are indeed water, but they're basically shallow waters, kind of basically like the continental shelves that we see today there, that are covered by oceanic waters that are far less deep than what's in the deep oceans there. Okay, so that's a brief history of. Oh,
sorry, Paul. I moved ahead.
That's okay. That's all right. That's the next slide anyway. That's a brief history of how what we see in Canada today came to be, and basically what I wanted to concentrate on was, given the time that I have, is that there's an area in Alberta that wow it's an amazing, fantastical, one of a kind type of region that I strongly encourage people to go and see if you're out that way. This map indicates that area, and excuse me. The basically what the area is the Badlands of Alberta. This map shows the locations, and if you can roll the next one. Here's a zoomed in area. This is a zoomed in area of the Badlands that I'm going to show you a pile of slides on. It's located along a stretch of land some 100 to 150 kilometers east of Calgary, and this area was carved out by the enormous rush of water that occurred with the melting waters of the retreating glaciers of the last ice age that began some 15,000 years ago. Specifically, those waters carved out a broad and deep valley along the course of the present Red Deer River, and the slides that follow take you from the canyons in the north, starting at Horseshoe Canyon, down through Drumheller and eventually down into Dinosaur Provincial Park, a fascinating location. Next one, please. So the sign at the entrance of our first site that we'll have a close look at indicates your location, as well as areas. Oops, sorry. As well as areas relatively nearby this area of interest. Essentially, some of the Badland areas that are located along the course of the Red Deer River Valley. And just to clarify, oops, lost my place there again. Next one, please. Just to clarify, the term foundation or formation that I'm gonna throw at you a few times here, it's used by geologists to refer to a package of rocks with uniform characteristics across large distances. The Horseshoe Canyon Formation, which is well exposed in the Drumheller area, has repeated layers of drab-colored sands, silts, clays, and coals, and those layers extend throughout southern Alberta. Can you hear me okay, Dave? I just got a notification that my internet's connection has become unstable. Am I good still?
Yeah, you're still good. You're wobbling a little bit, but you're quite clear.
Okay, great. Thank you. So where am I? Oh, okay. Yeah, just a matter of definition there, excuse me. If you can roll the next one. These are views from the Horseshoe Canyon Formation, and it's kind of your first glimpse into some of the unusual terrain of the Badlands. There we go. Again, what this is just a couple of shots showing a panorama sliding or moving to the right of the area as viewed from the rim of the Horseshoe Canyon, and you can see you can see quite a bit of detail even from this view, even though you're looking down into the canyon. It's quite obvious that there are major layers laid down in the formation of this landscape. These formations that geologists refer to, they can be, you know, a few meters thick to many kilometers thick, but by definition, they must geographically be continuous and mappable over many kilometers. Most formations represent deposition and burial of sediments over thousands to many millions of years. Excuse me. And formations are basically best thought of as packages of rock formed in one kind of ancient environmental setting, such as a delta, shoreline, large lake, desert, ocean, volcanic landscape, etc. They have that in common. Next one, please. Oh, there we go. Okay, because formations reflect the environmental settings that persisted over time, a stacked succession of different formations, as you see here in these different layers, they allow geologists to assess how a region evolved environmentally over time. For example, in Alberta, it's common for marine formations like the Bear Paw to alternate in sections with non-marine formations like the Horseshoe Canyon Formation. This alternating vertical pattern is evidence for a multi-million year geological history of advancing and retreating seas across Alberta. Next one. This close-up view again from the Horseshoe Canyon shows just how dramatic and abrupt the transitions from one type of layer can be to another. In one layer, you can have coal-bearing materials. Certainly, that was of significant importance in Alberta in the last century and continues today. Not so much coal, but certainly the oil and gas. You can see the strata that would contain these versus an entirely different material laid down in a different era. And so subject to different environmental conditions at the time of its formation. Excuse me. So next one, please. So moving along from the Horseshoe Canyon, just to the northwest of Drumheller, there's an area called Horse Thief Canyon. I love the names. I don't know how well you can read it, so I'll just read a portion of the sign here because I find it's quite interesting. It says this area of the Red Deer River Valley earned its name during the early settler years when ranching was the main industry here. Thousands of horses ranging from here to beyond the Hand Hills to the east. Legend has it that horses would disappear into these canyons of the Red Deer River Valley, later to reappear carrying a different brand. Hence the name Horse Thief Canyon. Some of the most significant fossil discoveries ever made in the age of reptiles have been discovered in Dinosaur Park and indeed in this area surrounding the Badlands area. Next one, please. So this next group of slides, it'll just auto advance there, so I'll just let those play out. But this area is similar to the Horseshoe Canyon that we saw, but the Red Deer River Valley is broader here, and really gives you a feel for just how wide the river must have been at the time the glacial meltwaters cut through their way through the land. Are those slides advancing at all? Or?
Yes, they are. Yeah. You've got a bit of a time delay at your end, I think. I've gone through 3 slides since you said that. I'm on my 4th now.
Are we continuing? Are we advancing there, Dave? I don't know. I can't see that on my end.
Yeah, we are advancing. Yeah. I'm on slide number 6 now from the time you said automated. Are you frozen at your end there, Paul?
Okay.
Sounds like you're breaking up a bit. Okay, Okay, Paul, you are breaking up right now. Okay, so it sounds like we're having some technical difficulties at Paul's end there. Yeah, I don't know if I can pause this here. Hang on a second.
Can you hear me now, Dave?
Yeah, I can hear you now. Yep.
Okay. Yeah. Sorry. Again, that was my end. I lost the connection there. Perhaps you could go back just a slides. Hopefully, our connection will stay stable.
Okay. I'm just backing up a little bit here.
No, I just got another notice that it's unstable. Are you still with me, Dave?
Yeah, I'm still here. Yeah, I'm still here.
Dave, are you still with me?
Yes, I'm here.
I get you.
Okay, Paul, I'm not hearing you at all. Sorry about this, folks.
Dropped it again there. Are you with me, Dave?
Yeah, I'm here. Yep.
Okay. Okay. This it's not playing happy with me, but we'll see if we can proceed.
Where do you want me to advance the slides to? There's a bunch of sort of similar pictures of the Badlands. Do you want me to move it to the river then?
Actually, I'll give it to you. I'll let you know in here in a moment. I just have to reconcile that with my notes here. I think we can leave it. Yeah, we can let it run from here.
Okay.
And perhaps what you can do, because yeah, okay, so they seem to be advancing.
I'm just advancing them a little bit faster just to catch up here.
Okay.
So
yeah. So these are just views when you descend down into the Red Deer River Valley at this point at the Horse Thief Canyon. This is an interesting area because it's a little bit wider than some other places. And as a result, there are roads that you can actually drive down into, and a few places where you can cross over the river. There's also numerous hiking trails there, and you can see from the rim of the valley the Red Deer River meandering through the landscape there. That river carries a lot of sediments as you and you can see these quite readily when you
yeah, I think we've lost you again there, Paul. Okay. Let me just see whether Paul has dropped out. It's quite possible that has happened here. Hang on a second here. He's having some internet challenges. Yeah, Paul is still here. You there, Paul?
There, I just got back. This is sorry, folks. This is a problem at my end. I'm having the connection drop on me on a regular basis here, which is really unfortunate and disruptive.
Okay, so we're at the picture of the ferry crossing the river. Have you dropped out again, Paul? I think he has. Sorry about this, folks. Okay, Paul has dropped out again. I think what we're going to do as soon as Paul gets back in is I'm going to move on to the observation part of the meeting, or some announcements and observations, and give Paul's internet a bit of a rest. Oh, here he comes back on. Okay, Paul's back in. Yeah, Mick, yeah.
Are you with me?
Okay, Paul, I think what we're going to do, we're just going to move on to the announcements and observations and give your internet a little bit of a chance. Maybe there's people are streaming stuff. And we'll come back to a little bit later in the meeting. How's that?
Dave, are you with me?
Yeah, I'm here. Can you hear me, Paul?
Yeah. Can you hear me?
I can hear you.
I don't know, Dave. I think I'm going to lose you again.
Okay. Why don't we move on, Paul, and we'll resume your presentation at a later meeting. How's that? I think that's probably the best bet. So
Dave, yeah, I just got you there. I think we're going to have to leave it for yeah. This is breaking up on me every minute or two, and it's making it unusable.
Okay,
sorry
not a problem, Paul. We'll resume at another meeting. Okay.
Okay. Sorry about that, everybody.
Okay. So let me give me a half a second here, folks, while I just rejig things, and I'm just going to move the PowerPoint slides down a bit and then resume just after Paul's talk. And then we will we'll get Paul back at another time. So really appreciate your attempt there, Paul. And here we go. Slideshow from current slide. No, sorry. Wrong one. Give me a second here. Okay, there we go. Let's just give me a second here. Back to the meeting. Okay, so Paul's going to come back at a future time, and maybe if we can get Paul back in person, that would be awesome. This is the challenge sometimes of doing Zoom meetings. Paul's out in a remote location, and sometimes the internet is just not quite there. Okay, so moving on then. We're going to have a couple of announcements here. We'll take a 5-minute bio break, then we're going to do our observations. So just to let you know that we do have some open positions in the RASC Ottawa Centre. We are still looking for a meeting chair. I'm currently the interim meeting chair, but I'm also the president. I'd love to offload that particular job. And if you need any sort of details on what's involved in that, please email me, president@ottawa.rasc.ca. But basically, you're scheduling speakers for upcoming meetings, and you do the role like I'm doing tonight, and trying to move things forward. We also have openings for 2 counselors, 2 national representatives. And because we're starting to move back in person, the hospitality position is particularly important. We had a couple there that was doing it for many, many years. They provided coffee and cookies and soft drinks for folks after the meeting was over at the Aviation and Space Museum. So we need somebody to take over that particular position. And also we need somebody to take over the light pollution abatement position on council. So please consider those. And sorry, I just realized I have my camera covered up. Okay. Mick Wilson, who is our awesome website designer, would like to share with you some of the new and improved things that are coming our way. So go for it, Mick.
Alrighty. You hearing me, I hope?
Yeah.
Can you stop sharing so I can share, please?
Oh, there you go. Sorry.
No probs. Okay, and we're doing the screen thing. Yes. Good. Still saying yes. Okay. So, hi, everyone whom I've not seen for the last 8 months or so. Guess I was hatching a baby. What I want to give you a 5-minute update on is what's happening with the website, which, as you can see here, was basically fossilized back in about February this year. And the reasons for that are technical, organizational, and whatever. But I'm here to say, in the course of this afternoon, I whipped up a wonderful new website. And here's what it looks like. I can click through on the new site tab on the menu, and voila, we get this thing. I would like to say that I whipped this up in 15 minutes this afternoon, but that would be a lie, and you don't want me lying. So what you're looking at here is where the website's going to go over the next couple of weeks. It's a whole new design. It's mobile friendly. It's much lighter. It's much simpler than you saw in the previous iteration, which I inherited in 6 years ago, and was built around a whole different framework, which was not as mobile friendly, not as easy to maintain, and was reaching the end of its technological life. So here is the new improved version. As you will see, a lot of the existing content is still there about the RASC, what we do, what we provide to our members, how we provide that stuff to our members. The guide for new members is still there. How to take advantage of the various facilities that become available as a member of Ottawa RASC. All this is up there and live for you at the moment. Astronauts, our lovely, well-received monthly newsletter, also repackaged into this new format, including the PDF version, which for some reason I'm not seeing, so I won't say that out loud. Information about our star parties, what's coming up in 2024. This is now being maintained by Katie rather than by me. Yay, it makes everything more current, flexible, and on the ball for our partners. Similarly, knowledge about FLO, Fred Lossing Observatory, what's going on and what's going to be going on. Again, the usage guide. the Ted Bean Library, all the telescopes that are being maintained by Peter Schutt and so on, all there ready to click through, pick up more information, contact Peter, and get back to being able to use these things plus their accessories for your own observations. Similarly, the Stan Mott library, the books, the DVDs, and so on, again, being moved over into the new format. This is obviously an incomplete list, and at that point, I will go to my final slide about our ripping new website. It offers a cleaner design. It offers mobile-friendly access. From a maintenance point of view, it's got a much better back end. Whoever I hand this off to in the future will have a much easier time. The intent is to bring forward all your old favorites. What I need to know is the priority for bringing them forward. I don't know how many of you appreciated the observation sections or the observation reports on the old site. Let me know. I will build up priorities accordingly. And of course, this then becomes a work in progress. Yes, there are going to be glitches. There are things that I've overlooked, need to be corrected. It will go live when I figure that it's ready enough. But in the meantime, I'm inviting your suggestions to myself as webmaster at ottawa.rasc.ca in order to help guide this process. If there are any questions right now, happy to take them. Otherwise, thank you, Dave.
Well, thank you, Mick. You've done an awesome pile of work to get this done. So we've moved from Drupal over to WordPress. Is that correct?
That's it.
Yeah. So I know that certainly WordPress is much easier to work with. I did look at Drupal once and I pulled all my hair out. That's why I'm bald now. Anyways. So so we can access that site from our main site. Is that correct? There's a new tab on our existing site.
Right. And in the next week, 2 weeks, I will do the switch over.
Super. Okay, well, we really look forward to that. I don't see any questions here. Lots of comments from the C here. Great job. Yes, it looks great. Yay, WordPress. So I think we're going in the right direction there, Mick. That's super. Thank you.
All righty. Thanks, Dave.
Okay. So, Jim.
Good evening, everybody. As you heard earlier this evening in Dave's cover of what's coming up this month, we have a partial solar eclipse tomorrow between noon and about 2:30. The peak is around 1:15. The forecast is for a mixture of sun and clouds, so fingers crossed that we'll be able to see anything. So there is a public event planned at the chapter's parking lot, Silver City. If anybody's familiar with the east end of town, it's where the Silver City movie theater is located, 2401 City Park Drive. There'll be a number of our members out there with solar telescopes, providing views, hopefully, of the sun with the eclipse happening. And we will also have a big stack of solar glasses. Andrea's law firm paid for hundreds of these to be made to donate to people. So these are going to be there to hand out to everyone and to talk about not only the eclipse happening on Saturday, but also planning for the eclipse, the total solar eclipse that's happening in April, which is very exciting because it's an hour drive from Ottawa to get into the path of totality. So that's pretty exciting. So come out and see us. Should be a lot of fun. Fingers crossed for some clear skies. If you want more info, if you want to volunteer, bring your own scope or whatever, you can contact me at the email address there in the bottom right, top-jimmy@rogers.com. Thank you.
Thank you. So, folks, we have another outreach opportunity coming up. I've been working closely with the Ottawa Public Library and recently with the Rockcliffe Public Library. I've done some presentations to both the younger kids and adults and older kids, and they're going to be having a star party coming up this Monday at 7:30 p.m. in the Rockcliffe Park Dog Park. There's quite a bit of open space there. And I could really use a few more folks with telescopes to help me out with this event. I've got 3 telescopes so far. I don't know how many people are going to show up. Right now, Monday's looking really good, according to the various predictors. So it'll probably will happen on Monday. But if you could email outreach@ottawa.rasc.ca, if you could help out, that would be awesome. And when you do respond, we'll send you more details as to exactly where we're going to be in the park here. I'm afraid that that map I've got up there is rather small, but it's and parking is a little bit tight down there. But the library is going to be setting up white balloons from where you enter the park to where the telescopes are going to be. Got a good view of the southern sky. So that's this Monday. Starts at 7:30. I would say we should probably be there at least 6:30 or earlier to get our telescope set up while it's still daylight. And as I said, the rain date is Wednesday, but right now Monday is looking very good. Okay, so I appreciate your help with that. And we're going to take a 5-minute bio break. And when we come back, we'll move into the observations. Oh, that's not it. Any other guesses as to what your weight is? Okay. You can either do it in pounds or kilograms. Okay, we're going to resume things here. Let me just close the chat window here. And the correct answer is 34 kilograms or 76 pounds. So all those folks who want to travel to Mars, there's a weight loss plan for you. Okay, moving on. We're going to move into our observations. And Richard Taylor is our first person here. So just give me a second while I bring him up. Oh, good to see everybody on the screen here. Okay, there you go, Richard. And there we go.
Okay, thank you very much. And sorry I wasn't here for the last meeting, but I was actually out at a cottage near the North Frontenac Dark Sky Preserve. So I was quite busy taking lots and lots of photographs out there. A wonderful time, had many clear nights. So I have quite a few pictures that I'll be sharing over the next few months. Here's one that was fairly new to me. This is the Cave Nebula, or Caldwell number 9, or Sharpless 2.155. It's a very faint and reddish nebula in the constellation of Cepheus, which is almost directly overhead at the end of August. So because I had the dark skies, I was taking fairly long exposures of 2 minutes, and this is about an hour in total of integration. I'm very happy to see all of this nebulosity, but the interesting part of this nebula, and the reason its name is the Cave Nebula, is that there's a lot of dark, invisible dust that's hiding the stars and the other bright nebula behind it. Next one, please. Here's another one that was new to me, the Cocoon Nebula, which is Caldwell 19. It's in the constellation Cygnus. It's also known as IC 5146. Again, very faint, very red, and nicely overhead in September. Now, I have a fairly small field of view on my Astro camera, but I've seen in other people's pictures that there's quite a long tail of dark nebulosity again. You can just see the beginning of it going towards the top of this this picture, but it does extend for quite a distance away. So it looks like a dark comet. Next one, please. Here's the Triangulum galaxy M33, and I was taking pictures of this with my Canon M100 camera, and then I noticed in one of the Sky and Telescope magazines that I brought along, this is actually the November issue, there was an article about observing the Triangulum galaxy and all of the star clusters, globular clusters, nebulosity that you can actually see or photograph within that galaxy. So I went through the article and some of the maps that they gave there and managed to identify almost every object from the Sky and Telescope article on my own image. So this is my photograph, but the Sky and Telescope labeling of it. Next one, please. But when I got back from the cottage, I hadn't been doing much planetary photography while I'm there because I didn't have my big telescope with me. But when I got home, I was saying to myself, you know, I'm not quite happy with the level of detail I'm getting from my own telescope. Maybe it's the telescope. It's quite an old one. It was from dates back to the 1990s. Maybe I should try a newer one. So I actually borrowed an 8-inch Schmidt-Cassegrain from the Ted Bean Telescope Loan Library. I was lucky to find that it did fit onto my existing mount quite easily, so I didn't have to learn a whole new mount pointing routine. And yes, when I aimed it at Jupiter, I got my best view yet. So I'm thinking it's about time I retired the old telescope and see about getting a newer Schmidt-Cassegrain. So I've actually written an article about my older telescope for the Sky, just a minute, Astronauts this month. And I'd be quite willing to give that telescope to someone who could make use of it. No charge, just somebody who would like to have a nice big telescope. It's terrific for visual observing. I got my Messier certificate using it, but it's not the best for photography. It doesn't have quite the fine optics of the newer telescopes. Next one, please. Here's another example with the borrowed telescope of Saturn. And again, I was very happy to see that I could actually get the Cassini division in the rings. Next one, please. And then just the other night, on October the 3rd, I was out at FLO trying the 14-inch Schmidt-Cassegrain telescope again with my Canon M100 camera. And I was hoping to get the planets. It turned out the seeing was really terrible that night, so I didn't get very good pictures of the planets. But I, on a whim, kind of thought, well, maybe I'll try the Triangulum galaxy again. So this is just the central portion of the galaxy. And it was quite amazing how much detail I could get. This is only very short exposures. I wasn't trying for anything too fancy. And I was, as I say, hoping to game at the planet, so I didn't have it set up for guiding. So I was using, what was it, 15-second exposures. This is a stack of about 30 15-second exposures. And the details came through quite beautifully. The mount on that telescope is very, very smooth, very precise, so that even without guiding, the stars are very small and circular. So this is just an example now of what we can get from the Paul Commission Observatory. So next month, I'll maybe show a few more from my North Frontenac expedition. Thank you.
Thank you, Richard. Jim Thompson, are you there? I don't see you on camera. I think he stepped. Yeah, he's there. Okay.
I think you mean Jim Sophia.
Was it Jim Sophia's next? Sorry.
Yes, I
Wrong
believe.
Jim. Sorry. Okay.
Well, that's okay. I was expecting to see something from Jim Thompson. All right, folks. Well, this image was taken with the Lunt 60 millimeter H alpha scope. The scene was average that day. I was using a ZWO ASI 174 mono camera. And this is the best 20% of 2,000 frames taken in fire capture and processed with IMPPG, Topaz Studio 2, and Affinity Photo 2. Next one, please. This is an active region on the sun, and it's marked by high magnetic fields which trap heat and energy. These stored gases burst at some point in time with the release of energy, such as solar storms and coronal mass ejections. Dark sunspots, as you can see, and plages, the lighter areas that you see, often accompany active regions. The long dark filament on the left is also a solar storm. Next one, please. And on this image of the complete solar disk, I used the tone curve editor in the program IMPPG, which allowed me to invert the image to get greater detail of the surface areas and prominences. As you can see, the solar disk is covered with hair-like spicules, which are dynamic jets of plasma in the sun's chromosphere. The darker areas on the solar disk show active regions where sunspots are located, as I previously mentioned. The long pencil-like structures in the middle are filaments, which are solar storms in the chromosphere. Prominences are actually filaments that you see on the periphery of the solar limb, such as the one you're seeing on the right side of this image. I would have loved to take an animation of this beautiful prominence, but perhaps one day in time. Thank you.
Thank you, Jim. Sorry to get the Jims confused there, but there's only
No
one.
problem.
There's only one Bob. There we go, Bob.
How do you do? Most of the images tonight are actually Oscar's image challenges. The Pegasus dwarf galaxy was only discovered in 1950. In 1975, it was found to be part of the local group. It is about 3 million light years away. Next image, please. This galaxy was discovered by William Herschel in 1784 and is about 150 million light years away. The intense star formation activity is attributed to a merger with a smaller galaxy. Next, please. This nebula is also called the Butterfly Nebula, but I'm zoomed in too much for it to look much like a butterfly. Next, please. This small, bright, open cluster of stars was discovered by Charles Messier in 1764. It can be seen with binoculars. It is close to the Earth, being only about a bit more than 5 light years away. I've seen this cluster in a telescope, but did not realize at that time it was surrounded by hydrogen alpha nebula until I processed this image. Next, please. The Triangulum galaxy is 2.7 million light years distant and is the third largest member of our local group. The Andromeda galaxy and our own Milky Way are bigger. I'm quite fond of those red hydrogen alpha areas. Next, please. The Elephant Trunk Nebula is a concentration of interstellar gas and dust located about 2,400 light years away from Earth. It is called the elephant trunk because in visible light, the bright edge of the dark central cavity looks like an elephant's trunk. The dark cavities in the nebula are caused by the stellar winds from some very young, less than 100,000 years old stars in the nebula. Next image, please. The Whirlpool Galaxy is the first object that I ever photographed using a telescope. That was in the year 2002. Last month, I gave a talk about combining my observations from 2009 to the present day in one image. This made a 120-hour exposure. I mentioned it would be fun to run this image through a modern artificial intelligence deconvolution routine. Thanks to some help from Oscar Echeverry, here is that image. When you combine 120 hours of exposure with AI deconvolution, the amount of detail can be astonishing. This is without doubt the best M51 I have ever taken. Thank you.
Thank you, Bob. So I'm going to turn it over to Oscar here. Let me just spotlight you. There we go.
Hey, good evening, folks. Just got two images this month. This one here is NGC 7479. This was, I believe, 18 hours and 57 minutes of exposure. So I managed to get a lot of that. The integrated flux nebula, sort of that cloudy, wispy stuff you see in the background sky. Can you hit the button there, Dave? Just a closer view of the galaxy there. But yeah, as Bob mentioned, it's about 150 million light years away. It's a barred spiral in Pegasus, I believe. All right, next slide, please. This is the Ghost Nebula, just in time for Halloween here in a couple weeks. There's a reflection nebula in Cepheus. This particular image is about 16 hours, 54 minutes of exposure. Let's take in that stretch of clear nights that we had in mid-September. So between September 14th and the 22nd, about 7 nights of exposure there for about 17 hours. Both this, can you hit the button there? Sorry, Dave. Both this image and the galaxy before it were taken with my 11-inch Edge HD and the ASI 2400 MC Pro. All right, that's it for me this month. Thank you.
Okay, thank you, Taras. And welcome, Malcolm. Let me just replace the spotlight.
Thank you. Hello, everyone. Yeah, the great weather that we had in September and October, a great reprieve after all that long cloudy weather we had during the summer. So I took the opportunity to do some narrowband imaging. I got a couple images here, 3 different nebulas, all in the northern sky around constellation Cassiopeia. And this is the well-known Heart Nebula. And with narrowband imaging, if anyone isn't familiar, you shoot with a monochrome camera through a series of narrowband filters that let in extremely narrow bands of wavelengths that are equivalent to the emission wavelengths from the nebula. And those are typically sulfur, hydrogen-2, and oxygen. And then when you recombine them into a typical RGB kind of picture reference, you get that classic kind of Hubble colors of those gold, copper colors and the blue, which is really, some people, refer to it as a false color. A typical one through natural would look a little more red, but it's an attractive way to kind of look at these nebulas. So this is the Heart Nebula, and in the middle of it is a cluster in Melotte 15. And these young stars in that cluster are emitting a lot of solar wind that is pushing out the gases to create that very heart-shaped nebula. Next one. This is two neighboring nebulas. The one on the left is the Bubble Nebula, and you can actually see the bubble in the blue there. If there was a way, I don't know if you can expand on that picture or zoom in, maybe
Not really, no.
Yeah, okay. But it's an interesting object. And in the center of that is a very intense, bright O-type star. And that the radiation from that star is pushing gases out from that molecular cloud around it to form the bubble. Eventually, this star is going to burst into a supernova. The bubble will burst, but I think that's long after we're gone. Over on the right, well named as well, as the Lobster Claw Nebula, and it has a few other kind of fascinating features. If you look up at the top pincer, you can see a small star cluster up there, and there's a bright nebula which is creates that spot. It's called LINS. It's an LBN. I've forgotten the number. That is the bright nebula, kind of in the middle of the claw. So lots of interesting colors, and because of the successive numbers of dark nights, I was able to get, I think, 32 hours on this one, probably the longest I've ever had a chance to expose. That's it for me. Thanks.
Okay, thank you, Malcolm. Okay, we have Rick next.
Good evening, all. Yet another attempt at UGC 1263, also known as PEGDIG, the Pegasus Dwarf Irregular Galaxy. I should mention all these images that I'm showing this evening are all taken with the 10-inch f4 Schmid-Newtonian with a ZWO ASI 2600 MC Pro camera. This is about 4 hours of exposure. And the interesting thing I found about this is it's actually a companion to M31. It's interesting that just below it, there's a very nice little edge-on galaxy, and then up in the upper right-hand corner, a nice open spiral. And I'm going to try and do this one visually sometime in the next month. See if I can pick it out. Next, please. So I've been shooting some open clusters, and this is NGC 1342 in Perseus, magnitude 6.7, about 14 arc minutes in diameter. You can see it's quite an irregular shape. The clusters are often assigned a Trumpler classification, where there's Roman numerals 1, 2, 3, or 4 of decreasing concentration. So this is a 3, being relatively unconcentrated. The next value is an Arabic number, 1 to 3, for 1 being all the stars are relatively the same brightness, and 3, the stars cover a great range in brightness, and this is rated as a 3. And then there's a letter classification for P for poor, M for moderate, and R for rich, and they're divided on 50 stars and 100 stars. And so this one's rated as poor with less than 50 stars. And the other addition that they sometimes make is an N for involved nebulosity. And this is only about an hour and a quarter exposures. So it's already starting to show up some diffuse sort of brownish nebulae, which of course wouldn't have been visible on the plates they would have done the classifications on. Next, please. So this is the south end of M31, the Andromeda Galaxy. At the center is a bluish area that's called NGC 206, and that's an enormous star cloud or OB association in Andromeda. So an OB association is a grouping of new stars, many of which are spectral classification O or B. So they're very bright blue stars. And in fact, there's apparently over 300 stars in this area that are more than 9 magnitudes brighter than our sun. This, the reason for this image, I have the ZWO dual band filter, so it exposes in H alpha and O3 bands. And I wanted to see what kind of an image you get. So this is 3.8 hours total exposure. And you can see the color balance is quite nice. So what I did was I stacked all these in Cyril, and then it has a photometric color calibration where you just you tell it an object that's near the center of the field. It plate solves the image, gets the photometry for all the stars in the picture, and then color corrects it so that the photometry is correct. And this is what I got. And you can see there's a lot of nice little H2 regions scattered about. I quite like the dual band filter. However, they are both relatively wide bands. So I discovered after some hours of exposures that they aren't good enough to cut through moonlight or heavy light pollution. Next, please. This is NGC 1893. If you know the frying pan asterism, sort of in south central Auriga, the Flaming Star Nebula is just to the west of it, and this is just to the east of it. And you can see some quite nice nebulosity involved, dark areas and so forth. It's rated as either a moderate or rich cluster, depending on where you read the classification. The nebulosity itself is called IC410, and there's another sort of almost a backwards G, sort of just halfway up to the top of the frame, which is Dolidze 18, another small open cluster. And reading about this, Chandra observations, they've determined that there could be as many as 4,600 young stellar objects encased in the gas and dust, invisible to our eyes. So this is 3.1 hours of exposure. And next, please. So one of the projects I've been working on is to try and build an all-sky camera, and still messing around with it a bit. The camera uses a 2.5 millimeter ZWO lens and an ASI 678 MC color, uncooled color camera. The camera has very high IR sensitivity, and as a result, that totally washes out the colors and turns the trees all pink. So I ordered a UV IR cut filter, which can replace the chip, the protective window over the chip, and gives you much nicer color balance. Although you can see I'm still a bit heavy on the green here. But anyway, so I replaced that little window and stuck the camera outside. Was unexpectedly clear, and just let it run all night, and picked up this bolide on the 9th of September at 2:30 in the morning. So I was quite pleased to have that happen on its first night out under the stars. That's all I have.
Okay, thank you, Rick. So I'm going to turn it over to Taras. And there we go.
Hello, and yeah, a few of my pictures from Manitoulin Island. So we had we had the chance to travel there with Andrew Brown, Konstantin Popov in the second half of August, right before the beginning of Starfast. We spent 4 nights there, 3 of which were suitable for observation, 2 of which were without clouds, and 1 of which was without smoke. So there was a chance of imaging a few objects and observing. But as for our location, I guess it was quite good yield of clear skies. And the highlight was a really dark environment. The Manitoulin Island in the middle of Huron Lake is known for its really dark skies and really contrast nice stars and Milky Way. The equipment which we had with us was both Star Adventures, the trackers, and the telescopes. You can see Andrew's tent around the telescope in the lower left corner, which protected from the wind. It's nice equipment to have with you when you expect a bit windy weather, so it protects you from shaking. And this picture is courtesy of Ben Dueck, who was there with his drone and shot a very nice video. This is a frame of it with it flies through the island and some photography from there. Let's go to the next slide. So this is the Veil Nebula. It's a cloud of heated and ionized gas and dust in the constellation Cygnus. It's a supernova remnant. The source supernova was a star 20 times more massive than the sun, which exploded between 10,000 and 20,000 years ago. At the time of explosion, the supernova would have appeared brighter than Venus in the sky and visible in the daytime. The remnants have since expanded to cover the area of the sky roughly 3 degrees in diameter, or 6 times diameter of the moon. This took me about an hour and a half to image during that clear night, and I'm quite happy with the result. This was taken with 135 millimeter lens and modified DSLR camera. Let's go to the next one. So the bright star in the center is Gamma Cassiopeiae, about 550 light years away in the constellation of Cassiopeia. And the ghostly cloud of dust and gas around it, it's the Ghost of Nebula, or IC63. It's stunning and slightly eerie nebula. It's been shaped by radiation from this unpredictably variable star, Gamma Cassiopeiae. It took about, again, an hour and a half to image this object, the very same lens from Manitoulin Island, and the ghostly shape is kind of in a good coincidence with upcoming Halloween, even though I wish I had a bit closer zoom in for the shape of the ghost itself. Let's go to the next slide. And yes, this is well-known object. Two of them actually here, or even more. So the Lagoon Nebula in lower part of the image is well-known object. It's actually also 2 or 3 objects in one, with the open stars, open clusters, the star formation region, and the heated ionized gas radiating hydrogen glow above it. There is a Trifid Nebula, which also consists of ionized gas that's glowing, and the reflection nebula above it, which glows a bit bluish. So this was one of the highlights for the trip for me, because we can see, all of us could see this lagoon with the naked eye as a milkish glow, because the sky was so dark, so bright, so contrast, that this dim object could have been seen just with no binoculars, just with the naked eye. Let's go to the next one. And this is also, there are 2 objects in this picture, NGC 7380, which is a young open cluster of stars in circumpolar constellation of Cepheus, discovered by Caroline Herschel, and the surrounding emission nebulosity is known colloquially as the Wizard Nebula, which spans an angle of 25 arc-minutes. The nebula is extremely difficult to observe visually, usually requiring very dark skies and oxygen-3 filter. While the complex of the stars is located about 8.5 thousand light years away from us in the Perseus arm of the Milky Way. There is a lots of red in this image or oxygen glow because I used the modified camera and dual band filter, which was supposed to pick up a little bit of oxygen glow, but this was the night when the skies were polluted with the smoke, and this didn't turn out as contrast as I'd expect. Let's go to the next image. So this is back from May May 27. I am showing these pictures because I have been amazed by the amount of details shot or imaged with a monochrome camera, which I'm using for planetary. And in this case, it's quite large solar spot. You can see all the details, and the seeing the day, this was during daytime, was so good that I managed to get the granulate, the darker region, the penumbra, and it's if I'm not mistaken. So this is really was impressive for me to see with the naked eye, and I thought I would have to image that and share this picture as well. Let's go to the next slide. So this is Jupiter as seen from, if I'm not mistaken, end of August, around that time, and the highlight of this picture was a shadow of one of the moons passing right above the red spot. So the moon itself can be slightly seen right closer to the limb on the left, around like 9 o'clock, as an orangey spot, and the sun direction was from the left to right, so the moon cast the shadow right on the red spot. Let's go to the next slide. And another opportunity to image the planets was the night of September 30th, October 1st. The seeing was exceptionally good. I never seen such good seeing in our location, probably never. And I used the Starmaster, 18-inch Starmaster telescope from Fred Lossing Observatory to image the Saturn. I'm quite happy with the result. And that night, actually, it was so nice seeing that I managed to get some moons of Saturn, which I highlighted them manually by applying the mask, but I'm happy with the result, how they showed up in this picture. So let's go to the next slide, which is Jupiter from the same night. And one of its moons, I believe this is Europa. This image is actually even higher resolution than what it looks on the screen. So if it's uploaded on the website, you could see some fine details in the bands. I was completely, as I was saying, blown away by the quality of the seeing that night, with the amount of details that can be visually seen in the planets. And this is a good example of what the telescope is capable of delivering. So again, this was 18-inch Starmaster from Fred Lossing Observatory. And let's go to the next slide. While having such a good seeing, I thought that maybe let's try something really tiny. In this case, it's the moon of Jupiter called Ganymede. So I imaged it and was a bit surprised, I guess, to find out that some details did show up. So I enlarged it like 3 times in the upper lower right corner, while the image in the center is 2 times enlargement of the original video from the video frames that this image was built of. It's difficult really to relate to the actual the landscape of that moon because there is not much of references, but this was definitely something in the separate channels that I was imaging it with through the filters. So let's go to the next slide. And the same about Uranus. So Uranus was quite stable. It was not like a dancing spot. You could see the disk, you could clearly see the color, and I was happy with the result, even though it again didn't show much of the details. Unlike my previous attempts, like I got a little bit whitish shading in previous pictures of it, but this time it was just solid, almost solid blue with no details showing up. So let's go to the next slide. So again, the seeing was very good, and I couldn't have passed the chance to image the moon as well. So this is Endymion crater and Mare Humboldtianum. The floor of crater has been covered in a low albedo lava that gives it a dark appearance and makes it relatively easy to locate. The diameter of this crater is 122 kilometers and depth is 2.6 kilometers. That's the one on the upper in the upper right left quadrant. Let's go to the next slide. And another crater, this one is called Langrenus. It's located near the eastern lunar limb. To the south of the overlapping crater, there is a crater pair Vendalinus and the smaller Lemay. Diameter of this crater is 132 kilometers and depth about 2.7 kilometers. These images, by the way, are mirrorly flipped. So this was actually not western, but eastern limb. And I should have, I guess, rotated them before sending. Let's go to the next slide. And Petavius crater. It displays a real system named the Rime Petavius. The large central mountains are prominent formation with multiple peaks climbing 1.7 kilometers above the floor. The deep fracture runs from the peaks towards a southwest rim of the crater. And let's go to the next one. And everyone knows Tycho crater. It's a prominent lunar impact crater located in the southern lunar highlands, named after Danish astronomer Tycho Brahe. It's estimated to be 108 million years old. It's one of the moon's brightest craters with a diameter of 85 kilometers and depth of 4.7 kilometers. And the next slide. So this is Mare Crisium. So unlike previous pictures, this is not a mirrored image, but correct in terms of what we would observe on the moon. So this one is, the Mare is 556 kilometers in diameter and about 176,000 square kilometers in area. It has very flat floor with a ring of wrinkled ridges towards its outer boundaries. That's all from me. Thank you.
Okay, thank you very much, Taras.
Thank you.
Okay, so these were the observing challenges for last month, and I saw we got some of those in our observations. So the deep sky challenge for this month is Messier 72. It's a globular cluster in Aquarius. All of these challenges will be in our upcoming astronotes.
Yeah.
Hang on.
Yeah.
Sorry, just need to mute somebody there. The intermediate challenge is NGC 7331, a spiral galaxy in Pegasus. And our advanced challenge is NGC 1275. It consists of 2 galaxies in the process of merging. It's also known as Perseus A. Our lunar challenge is crater Franklin. It's a crater in the northeastern region of the moon, 56 kilometers in diameter, 2.7 kilometers deep. So here's a summary of the challenges, and as I say, these will be in our upcoming astronotes. A reminder that members are allowed to access the Fred Lossing Observatory, and we encourage you to use that wonderful facility. The next members only star party is October the 14th. That's tomorrow, and we have a new moon, so Hopefully the weather will cooperate. Here are some of the folks that keep our club running. And as you say, with the coffee and conversation, our hospitality host position is currently open. So we're looking for volunteers for that. We have an audience. I think at one point we had about 60 people in plus the panelists. So it's a good number for tonight. So thank you for all those. I apologize for the technical issues we had with Paul's talk, but we are moving back to in-person meetings starting in November, but it is a blended meeting. So if you're not able to come in, we still will be on Zoom. If you have ideas for speakers, comments, suggestions, please email meetingchair@ottawa.rasc.ca. So our next meeting is in person at the Canadian Aviation and Space Museum, and it will also be on Zoom, Friday, November the 3rd at 7:30 p.m. And I'm pleased to say that we have a guest speaker. She'll be coming in remotely, but that is Dr. Natalie Ouellette, who will be talking about the James Webb Space Telescope. There's been a lot of exciting things recently been released about that, and that's one of her areas of expertise. So I'm looking forward to hearing from her. And also Oscar will be doing a short presentation on some technicalities around telescopes. Sorry, Oscar, I don't remember the exact title of your talk. Okay, so thank you folks for coming out this evening, and clear skies. And again, if we can get a few more telescopes out for Monday night, that would be awesome. And please make sure you support Jim. And I'm sure you could use a few more telescopes out at the Silver City tomorrow. Okay, thanks folks. Have a good evening. Clear skies.